Happy Friday. Welcome to NTI Day 27. We're going to be finding all 6 trig functions in this video. As always, feel free to grab a piece of paper and write down the notes along with me if you would like to. So we've already learned about 3 of our trig functions, and that's sine, cosine, and tangent. And just as a reminder, sine is always opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Then we have 3 other trig functions, and they're going to be the reciprocal functions, which just means that they're the flipped version of our original functions. So first we have cosecant, and that is abbreviated to CSC. And cosecant is the reciprocal of sine, which just means that it's equal to 1 over sine, which is the same thing as just taking our opposite over hypotenuse and flipping it to be hypotenuse over opposite. And you're going to notice a similar theme for all these because it's basically the same thing. Secant is the reciprocal of cosine, which means it's basically 1 over cosine. So we're just going to take that adjacent over hypotenuse and flip it. And same thing with cotangent. It is the reciprocal of tangent. Sorry, I started writing the wrong thing under there. 1 over tangent is the same thing as cotangent. So instead of opposite over adjacent, we'll have adjacent over opposite. So if you just remember which one goes with which original trig function, it's not that hard to find them, you just gotta flip the fractions. So sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent. Now tangent and cotangent are the easiest ones to remember because they both have tangent in it, so it's pretty obvious that they go together. And then sine and cosecant go together, and cosine and secant go together. Those are easier to mix up because they've got opposite letters starting. So if you just remember, sine does not go with the S, it goes with the C. S to C, C to S, always opposite. There's never going to be S, S, C, C. They're different from each other. And that helps me remember it, but it can be a little confusing at first. So we're going to start with example 1. We've got this nice right triangle here. We've got a leg of 5, a leg of 12, and we don't know the hypotenuse yet. So first, just like in our last video, we're going to use the Pythagorean theorem to find that hypotenuse. So we've got 5 squared plus 12 squared equals x squared. And then 5 squared is 25 plus 12 squared is 144 equals x squared. I'll combine those together, get 169. And I'm going to take the square root of that. And I think that's a perfect square, which means that our hypotenuse x equals 13. So I'm going to write that down on my triangle. So now we've got all our values, which is great. We can move forward with finding all 6 functions. So we'll start with sine. Now here's my theta, top corner. Sine, opposite hypotenuse. Opposite's 12, my hypotenuse is 13. Cool. And now cosecant, like I just said, cosecant is just the opposite of sine, the flip, the reciprocal. So cosecant is going to be 13 over 12. It's not so bad. It's pretty easy. And then let's find cosine. So cosine is going to be the adjacent over hypotenuse. Adjacent is 5. Our hypotenuse is 13. And then we can find secant because that's the reciprocal of cosine. So we'll just flip that over, 13 over 5. Nice and easy. And then we can find tangent. So opposite over adjacent, 12 over 5. And then cotangent we'll just flip that fraction, 5/12. Not so bad. If you have any questions, make sure to email me about it or comment on the YouTube video. A lot of this is pretty straightforward, which is why it's a nice unit to learn over video. And then we have a second example, so I'll go over that one as well. So this one, we don't have both our legs. We have one leg and a hypotenuse, but we're still going to use the Pythagorean theorem to find that second leg. So I've got x squared plus 2 squared equals 3 squared. So we've got x squared plus 4 equals 9. Just go ahead and subtract that 4. X squared equals 5. I'll take the square root of that. But 5 is not a perfect square and it doesn't reduce. So we're just going to leave it as x equals the square root of 5. So that's the measure of that second leg of our right triangle. And then we're going to use our values to find our trig functions. So again, I'm going to start with sine. Theta this time is in that bottom corner of our right triangle. So sine of theta, opposite over hypotenuse. Opposite is radical 5, hypotenuse is 3. And since our radical's on the top, we don't have to rationalize this one. And then we can find cosecant just by flipping our fraction. So that'll give us 3 over radical 5. And now this one, we've got our radical on the bottom. So we're gonna have to rationalize it. And just like in the last video, to rationalize a radical that's in the denominator of your fraction, you're just gonna multiply the top and the bottom by that radical. So here, our cosecant will be 3 radical 5 over regular 5. Because whenever you multiply a radical by itself, it cancels the radical out and you're just left with the number underneath. So there's our sine and cosecant. We've got radical 5 over 3 and 3 radical 5 over 5. And then I'm gonna find cosine. So that's my adjacent, 2, over my hypotenuse, 3. Nice and easy. Find my secant. We're just gonna flip that fraction, get the reciprocal, 3 over 2. And there's no radicals, so we don't have to do any rationalizing. That's my favorite part. Tangent, finally. Opposite, radical 5 over adjacent, 2. Radicals in the numerator, we don't have to rationalize it. And then we'll find our cotangent. Flip that fraction around. We get 2 over radical 5. And then our radical is in our denominator, so we've got to rationalize that guy. Do the same thing we did for cosecant, and that should give you 2 radical 5 over regular 5. And that can't simplify any more from there. And that's how you rationalize that denominator to get a nice fraction. So that's our sine, cosine, tangent, cosecant, secant, and cotangent. I think the hardest part for this is remembering which one goes with which original trig function, but once you got that down, it's pretty simple. If you have any questions, as always, make sure to email me or comment or text me on Remind, whatever you need. We'll have an assignment over this type of question on Monday, and I hope you have a great weekend.